Hello, in this session I'm going to continue with inequalities. Now in the last session I've talked about very simple examples, so let's have a look at this again. Now suppose we have such an inequality, x is greater than 1. What this means is just that x represents a number in algebra, and it is telling us that x can be any number that is more than 1. So like it can be 1.1 or 1.01, or it can be 2, it can be 100, just any number more than 1. But x cannot be 1, and x cannot be less than 1. X cannot be half, or 0, or minus 2, or minus 10, and so on. Right, so that's what we understand about such an expression. Okay, now what I'm going to do now is to draw a picture of a number line to represent or to show this inequality. So let me do that. Now if I have a number line like that, goes in that direction, so I might have a 0 there, 1, 2, 3 and so on, and on the other side I have minus 1, minus 2 and so on. So that's a number line. Okay, now I'm going to look at this inequality. I know that x is a number that is more than 1. So 1 is there. So I'm going to draw a circle over the 1, and I'm going to draw a line to the right. Now, and I'm going to say that this line represents that inequality. So what that means is that the numbers which are covered by this line, that means like below this line, the numbers that are covered by this line are the possible values of x, like 2 or 3 or 1.5 or 10. Okay, all the numbers covered by this line are possible values of x, but all the numbers that are not covered by the line, that means to the other side of the little circle, all these numbers to the left cannot be x. They cannot be x. So in this way, I have a picture that tells me the same thing as the inequality. Okay, so a picture is always easier to see and quicker to understand, but it does seem a little troublesome to have to draw a rather big picture like this if we can just write x is greater than 1. So why do we want to represent the inequality using a number line? Now I will explain more about why we want to do this, and the main reason why we want to use a number line is to deal with more complicated expressions of inequalities. Okay, so we'll look at those in a moment, but right now I'm going to explain a little bit more about using the number line to represent the inequality. I'm going to look at a few different inequalities just to see what they look like on the number line. So Let me start by doing something quite simple. Let's look at x is less than 1. Okay, so I have x greater than 1, now I have x is less than 1. So how would I represent this on a number line? Right, I don't need that arrow there. Okay, so 0, 1, 2, 3, minus 1, minus 2. Alright, so x is less than 1. So let's go to the 1, okay, and draw a little circle on top of the 1. Now, x can be any number less than 1. So it can be 0, minus 1, minus 2, and so on, or it can be half, just any number less than 1. So to represent these possible values of x, I would draw a line over those values. So all the numbers below that line cover include the possible values of x down here. So that's like what we had in the previous example, except that the line goes to the left because we have a less than sign for the inequality. Okay, so that should be very simple. Now we are going to move on to a slightly different inequality. So I'm going to introduce this one. X is greater than or equal to 1. So that's a new inequality. I've not mentioned that before. The first inequality here is a greater than sign. So this means x is greater than 1. Now, what I have here is slightly different. If you compare the two, you see that there's an extra line below this inequality. Now that extra line means that x can be greater than x is greater than 1, or x can be equal to 1. So you see, if I cover up the top bit, it looks like a tilted equal sign. Okay, so what this sign means is greater than or equal to. Okay, that's how we read this symbol. Greater than or equal to. That one is just greater than. So here I say that x is greater than 1. There I say x is greater than or equal to 1. That's what that symbol means. But what does that mean about x if x is greater than or equal to 1? What it means is that x can be equal to 1, or x can be greater than 1. So that means that x equal to 1 is possible. X equal to 1 is a possible value of x down there. Whereas in the first inequality, x has to be greater than 1. And that means that x cannot be equal to 1. Okay, it can be any number more than 1, but it cannot be equal to 1. But this inequality, this greater than or equal to 1, means that x can be any number greater than 1. X can also be equal to 1, but x cannot be less than 1. So let's see how to represent that on the number line. 0, 1, 2, 3, minus 1, and so on. Okay, now I would draw that little circle on top of the 1 again. Now this time, instead of an open circle like this, I'm going to fill the circle. Alright, I'm going to fill up the circle so that it's a like a dot or a solid circle. Okay, so that point is supposed to represent the idea that x can also be 1. If I then draw a line over the numbers greater than 1, this is how we will represent x is greater than or equal to 1. So if you compare these two, okay, they're the same except that I have an open circle here, the inside is not shaded, but here I have a solid circle or big dot there. Okay, and this is supposed to mean, the open circle is supposed to mean that it can't be 1. Okay, that solid circle means that x could be 1. Alright, and likewise if I have x is less than or equal to 1, it's like that. So that is x is less than 1, and this symbol here with a less than sign and an additional line below it is called less than or equal to. So this, we read this as x is a number that is less than or equal to 1. Now if you compare the two, alright, in this case x can be any number that is less than 1. In this case x also can be any number that is less than 1, but x can also be equal to 1. Okay, and we would represent this extra possibility with this solid circle there and a line over the possible values of x. Okay, so again we see this difference. The main difference is that I have an open circle there and I have a closed circle there, or a solid circle. So that solid circle always means that the number below it is included as a possible value, but an open circle with a blank inside the circle always means that the number below it is not included, is not possible. Let's look at this example. Okay, the problem here is to solve this inequality. Now, if you remember from the last session, when we solve an inequality, we can do it in a similar way, using the same way as solving an equation. Okay, we would rearrange the inequality using the same methods in algebra until we have just x on one side and numbers on the other side, and then that would be the solution. Now, what we want to do now is to find the solution and show it on a number line. Okay, so let's do that. Now first of all, I have 2x plus 1 to the left. I would want to get rid of the 1. And I can do that if I subtract 1 from both sides. So let me Write a minus 1 there and a minus 1 there. So 2x plus 1 minus 1 would be 2x. 4 minus 1 is 3. So I have that. Then I have 2x on the left side, and I would like to get rid of the 2. And I can do that if I divide by 2. But then I must divide by 2 on the right side as well, so that the inequality remains correct, remains true. Okay? So if I divide by 2 here and divide by 2 here, 2 and 2 cancel to give 1, and I have x is more than 3 over 2. And that is the solution. Now if I want to display this on a number line, 0, 1, 2, 3, so on. Okay, I would locate this number, find this point on the number line, 3 over 2. 3 over 2 is 1.5 or 1.5, so it's there. Okay, so I will draw a circle on top to represent 3 over 2, and since it's a greater than sign, x is greater than 3 over 2, I draw a line over to the right. So that's the solution. All the numbers below this line are possible values of x. Well, let's look at another example. Suppose I have two inequalities this time. I have x is less than, x is more than 5 and x is less than 2. I have two inequalities. Now the idea here is that we want both inequalities to be true at the same time. Okay, that means that we want x to be a number that is greater than 5 okay. Right, okay, actually x cannot be true at the same time. We just want to find the possible values of x that would satisfy either one inequality or the other. So x is greater than 5 or x is less than 2. So let us show this on the number line, see what it looks like. Okay, start from 0, 1, 2, 3, 4, 5, 6. Okay, that's 2, 3, 4, 5. Alright, so I've the two numbers, 2 and 5, on the number line. So let's show it one by one. I have x more than 5. 5 is here. More than 5 means all the numbers to the right. So that's this. How about x less than 2? Now 2 is there. Okay. That's 2. And numbers less than 2 are to the left of the number line. So x can either be here or there. So this shows the possible values of x for the two, when you have the two inequalities together. Okay, now let me do something slightly different this time. Instead of x more than 5, let's look at x less than 5. And x, instead of x less than 2, what if I have x more than 2? So notice what I've done is that I've flipped the inequalities in that question. Okay, so I want to find an x that is less than 5 and more than 2. Let's try that on the number line. 0, 1, 2, 3, 4, 5, 6, 7. So that's 2, that's 5. Okay? Now, x less than 5. Let's look at that. That's 5. X less than 5 will be all the numbers to the left. Notice that I've used dotted line. Now, you will see in a moment why I do that. X more than 2. 2 is here. More than 2 are the numbers to the right. So that's what we have. So x is less than 5 are the numbers here to the left of 5. X is more than 2 are the numbers to the right of 2. Now that seems a bit confusing. We have this overlapping bit. What does it mean? Right. Now, what happens here is that if I add the word n down here, okay, if I really want an x that satisfies both inequalities, that means if I say that the x must be at the same time less than 5 and greater than 2, then the possible values of x would be just the numbers where the two lines overlap. Okay, and what this means is that if x is a number that is less than 5, according to that, it can be any number to the left of 5. But if x is a number that is more than 2, it can be any number to the right of 2. But if x is a number that is less than 5 and more than 2, so x must be to the left of 5, but it must be to the right of 2. So it has to be in between 2 and 5. So therefore, it is the place where the two dotted lines overlap, and the correct solution would be there. So I've drawn a solid line here to show that that's the solution to these two inequalities. So you can see the big difference between this and that. Now in this case, what I have is really this inequality. I have an inequality where x is more than 5, and that's where x is less than 2. Now if you look at the possible numbers, a number that is less than 2 is here. Now obviously it cannot be more than 5 at the same time. So a number can either be less than 2 or it has to be more than 5. So that's why I use the word or down here. Okay. Whereas on the other hand, I use the word and down there because x can be less than 5 and more than 2 at the same time. And that's when That happens when x is a number that is between 2 and 5. Like maybe 3, for example. So 3 is less than 5 and 3 is more than 2. Okay, that's 3. Okay, so far we have looked at inequalities involving the symbol x that is either greater than a number or less than a number. We will now look at inequalities involving two symbols or variables. That means x and y. Let's look at an example. Suppose we have this. Y is less than x plus 1. Now that is more complicated now. We have two symbols, x and y. What does that mean? It was a lot easier just now where we have just x and a number, like x is more greater than 1. So we can easily imagine what that means. It just means that x is any number that is greater than 1, like 2, 3, 4, 5, 6 and so on. But what does this mean? What does y less than x plus 1 mean? Okay, what it means is that x represents a number, y represents another number. Now we are interested in the possible pair of two numbers, x and y, that satisfy that equation. Now just to get a quick idea as to what this means, let's just make up some numbers and put it into the inequality and see what happens. Okay, let me try x equals to 1 and y equals to 2. Okay, if x is equal to 1, I have on the left side, I will have 1 plus 1. Sorry, on the right side I'll have 1 plus 1. On the left side, y is 2. So 2 and 1 plus 1. 1 plus 1 is just 2. So if x is 1 and y is 2, is this true? Is y less than 1 plus x plus 1? Is this true? It's not, because 2 is not less than 1 plus 1. 2 is equal to 1 plus 1. So that's wrong. So therefore, x equal to 1 and y equals to 2 does not satisfy this. So it is not a possible set of values for this inequality. Okay, now let me try x equals to 1 and y equals to 1. Okay, so y, the left side is 1, x plus 1, the right side is 1 plus 1. And the inequality is a less than sign. We look at that and we ask, is 1 less than 1 plus 1? Yes, because 1 is less than 2. So that's correct. So x equals to 1, y equals to 1. is a possible set of values for this inequality. You can see from this example that when you have two unknowns, x and y, things get more complicated. Now here is where it is really useful if we can have a simple picture to represent all the possible values of x and y. Now, how do we make such a picture? Well, we use a graph. If you remember, a graph has two axes, x and y. So let's try that. I have a graph. How am I going to represent the possible values of that inequality on the graph? The first step is to replace the inequality with an equal sign. Okay, so it is one of the steps in the method. It does not mean that that replacing that with an equal sign, so I just call that step 1. It doesn't mean that this is the same as the inequality. It just means that it's the first step in the method. We will plot the graph for that line. Okay, so let's do it quickly. Now, if I have y equals to x plus 1, now I know from what we learned about straight line equations and straight line graphs that the 1 there is the y-intercept. So just by looking at the 1, I know that the straight line has to pass through 1. Okay, let me just mark out some numbers. It's 1. Alright, let's pass through 1. And the next thing is, so I already have a point there. Okay, now let's just find another point and we can draw a line. Let's say x is 2. If x is 2, 2 plus 1 is 3. So y is 3. So that's y. Now I have 2 points and then I can draw a straight line. Okay, that's my straight line. So that's the graph, and that's the step 1. In the step 1 we draw a graph. Now in step 2, we go back to the inequality, right? Let me just write that out again. Y is less than x plus 1. Now, and we think about let's say I go to any point on the line, like that one, and think about what happens to this point if the equal sign changes to a less than sign. Now on this point, this is the point on the straight line, so it's a point that satisfies this equation. Okay, so on this point, y is equal to x plus 1 because y is 3 and x is 2. Alright, so 2 plus 1 is 3. Okay, 2 plus 1 is 3. So if I have a point on the line, it satisfies this equation. Now, but if I, so this is, let me write this out. That's, okay, never mind. So that the y there is 3 and x there is 2. Okay. Now if I change this to a less than sign, it means that the y must be less than x plus 1. Now if x is here, x plus 1 is the 3. Alright? So if x is 2, y is 3. But here we are saying that with the inequality, with the less than sign, the y must be less than x plus 1. So that means that I must have a lower value of x, or a smaller value of y, like a point there. Okay, so a point there would have a y that is smaller than 3, so it wouldn't be on the line, and then it would satisfy this inequality. Okay, so what this tells me is that as long as I have y less than the x plus 1, it is a possible set of values. For example, if the y value of that point is 2, okay, it would satisfy that. Now, you can imagine going to every point on the line, just pick another point there, and say that the point on that line would satisfy the equation here, this equation, but if we change the equal to a less than, that means that the point has to come below the line, because then the y will be less than x plus 1. So if you think about this for all the possible points on the line, it just means that any point below that line will represent a set of x and y that satisfy the inequality. So if I just pick any point, like that point, and you can try putting in the x and y, 1 and minus 1 for example, into the inequality, and you find that it would be satisfied. So therefore, if any point below that line has x and y value that satisfy this inequality, then we can represent the possible x and y values by, for example, shading the graph that is the area that is below the line. So that's how we could represent an inequality that contains x and y, that contains two unknowns, by shading an area on the graph. And this also means that any point that is above the line will not have x and y, will not have possible x and y values for the inequality. Okay, now there's one last bit that we need to add to this picture, which is that we have a less than sign there. It is not a less than or equal to sign, it's just less than sign, and this sign means that y has to be less than x plus 1. It cannot be equal to x plus 1. Alright, x equal to x plus 1 is not allowed. Now we have seen that y equals to x plus 1 is not allowed. We have seen that y equals to x plus 1 means a point on the line. So if x has to be less than x plus 1, if y has to be less than x plus 1, if y cannot be equal to x plus 1, it means that the point cannot be on the line. You cannot have a point on the line. Now to represent this idea that areas below the line is means represent possible values of x and y, but points on the line are not possible. We, instead of drawing a solid line, we make use of a dashed line. So I put little bricks along the line. Okay, so I have a dashed line to represent that points on the line are not allowed. Only points which are below the line in this shaded area are allowed. Alright, only those points in this area will have possible x and y values. X and y values that are possible for this inequality. So that's how we deal with x and y inequalities. Okay, now let me move on to the next example. Now in the next example, we are going to make this a little bit more complicated. Okay, I'm going to keep this results and this inequality. Just going to clean off the working. Alright, clean off some of this. Okay. Now suppose we have this inequality. Suppose that I have another inequality. Now this other inequality looks like this. Y plus 3 is more than 0. Y plus 3 is more than 0. Now this time, in fact, we only have one symbol, y plus 3. So I can, in fact, represent that on a number line. I don't need the graph. Alright, I only needed a graph just now because there are x and y. There are two unknowns. But this time I only have that. But what if I say that in this question, x and y have to satisfy both inequality. In other words, x and y must be less than x plus 1 and y plus 3 must also be more than 0. But then I have no choice but to make use of the graph to represent the answer. Okay, so how would I represent y plus 3 greater than 0 on this graph? So first of all, it is convenient to express that as an, or to write that as an equation. So that's the first step. Okay, let me start with the step 1. In the step 1, I do y plus 3 equal to 0. Okay, and I would plot a graph of that here. So what's the graph of y plus 3 equal to 0? Now let me try to write it with y on one side, like for the straight line equation. Now I can have y on one side if I minus 3 from both sides. So then I get y equals to minus 3. Now, what does this graph look like? Y equals to minus 3. How can I plot a graph if there is no x? There is no x down there. Now, if there is no x in the equation, it just means that x can be any number. Now, let me just make a table to make this very obvious. So let's say I have a table of x and y, and I just put in some possible numbers for the x, like maybe 0 and 2. So if you look at x equal to 0 and this equation, the equation is that y equals to minus 3. So if I imagine trying to do the usual calculation for an equation, when x is equal to 0, then using this equation, what is y? But there is no x in this equation. What does that mean? I cannot substitute 0 into the x there because there is no x. Now what that means is that if there is no x in the equation, we don't have to substitute the x. There is nowhere to substitute it. And in fact, the question really is that if when x is equal to 0, what is y? What is the value of y? Now if you look at this equation, you realize that we don't have to substitute x equal to 0 into the equation to find y, because the equation already tells us that y is equal to minus 3. We don't have to do any calculation at all. So when x is equal to 0, y is minus 3. And we know that without calculating. What about when x is equal to 2? Well, there is no x in that equation, and y is still equal to minus 3. So that's very simple. I just have to keep writing minus 3 for all the y for any values of x. So that's the whole idea behind this equation. X can be any value, but y must always be minus 3. So, what does the graph look like? Well, I already have some pairs of x and y values there, and I can plot the graph. Okay, so starting from x equal to 0, y must be minus 3. So that's minus 1, minus 2, minus 3. So minus 3. That's 1 point. And if x is 2, y is still minus 3. X is 2, y is 3. So there, I have 2 points to draw my straight line. So the straight line is here. That's my straight line. Now that we have our straight line, let's think about this again. Think about this equation again, y equals to minus 3. If you look at any point on the line, you see that the y is always minus 3 because it is a horizontal line. Okay, so if you have different points, the x will be different. But if you are on the line, then the y is always minus 3. So this means that if I have an equation with no x, but with just y equals to a number, then I know that it's just a horizontal line going through that number. So if the equation says y equals to minus 3, it is a horizontal line going through minus 3 on the y-axis. So once we understand this, you don't even need to make a table. You can just go ahead and draw a horizontal line through minus 3 on the y-axis. And it's that simple. Okay, so the straight line, the equation y equals to minus 3 is simple enough. Now, we now look at the slightly more complicated bit when we have the inequality. Okay, so in the step 2, y plus 3 must be more than 0. What do we do? What are the possible values of y that satisfy this inequality? Okay, what we could do is to rearrange this equation so that we have just y on one side, like for the first equation. So let me do that. If I have y plus 3, I can minus 3 from both sides. So on the left side I have y, on the right side minus 3 will give Just minus 3. So the inequality here is y is greater than minus 3. Now if I look at this line, any point on that line will have y equal to minus 3. So y greater than minus 3 means that it must be a point that is above the line. So if I pick any point above the line, that point has a y that is greater than minus 3. That's quite obvious because minus 3 is there and the point is up there. So that point, the y value of that point has to be higher than minus 3. Okay, and that's true for any point that is above the line. Okay, so what that means is that the whole area above this horizontal line are points that has the possible y and x values for this inequality. So if I want to shade the area for that inequality, I will have to shade all the area that is above that line. Okay, so remember that the area for this, the possible area for this inequality is the area above that line. Okay, I'm not going to shade it yet. I'm now going to go back to the first two inequalities. If you remember, the question was, how do I show the area of x and y that satisfy both inequality? How do I find the possible x and y for both inequalities to be true at the same time? Okay, so we know that for the first inequality, it is this area here. Alright, it is this area below the line that gives the possible x and y. So it's the whole area right down to as far as you can imagine. And for the next inequality, the area is the area above the horizontal line. So it's all the area up there. Okay. But what we really want is an area where the x and y's agree with both inequality, satisfies both inequality. We want both to be true. So if you think about the areas here, we have one area that must be below that line, okay, and we have another area that must be above the horizontal line. So what we need is an area that is common to both. We need an area that is at the same time below this line and an area that is above that line. And this area is simply the area in between. So if I shape that, that is the area. It's the area in between the two. So that would be the solution, the answer, okay, for the possible x and y when we have two inequalities. The last thing I'm going to do in this session is to make this problem a little bit more complicated for a second time. I'm going to do that by adding yet another inequality. Right. suppose we have this inequality, y plus x less than 2. Now I want to find the possible x and y that satisfy all three inequalities. So we have three inequalities now. Okay, as with the previous inequalities, what I'm going to do is to just look at this one first on its own and find out what is the possible area on the graph. Okay, now so what I'll do is I could rearrange that to keep y on one side. I can do that by subtracting x from both sides. Okay, subtracting x from both sides, I get that. So that's the first step. In the next step, I will replace the inequality by an equal sign to make an equation. Y equals to minus x plus 2. So that's a straight line equation. So you have already seen two examples. You know that I now want to plot a graph of this straight line. Okay, now that we are familiar with the format of the straight line equation, we know just by looking at this that 2 is the y-intercept. Okay, 2 is down there, so the graph will cross that point on the y-axis. So we have that. Now we just need another point to make the graph. So let me pick, say, x equals to 2. Okay, x equals to 2 is down here. Now, minus 2 plus 2 is 0. So when x is 2, y is 0. So the next point is that. I have my 2 points. I can draw the line. Okay, so that's my straight line. So in the next step, I would replace the equal sign by the inequality. Okay, so in fact my step 2 is just here. That's my step 2. I go back to the inequality and use that to find the area. So if I have this line, according to this inequality, y must be less than minus x plus 2. Now we can use the reasoning just now and say that, right, because when y is equal to minus x plus 2, it must be a point on the line. So if y is less than that, it simply means that the point must be below the line, so that the y is less than the minus x plus 2. So this is a simple way to tell us that the area must be below this line. There is another way, another simple way, which is useful to know, of telling where the area is. Now, from the two examples just now, you can see that the area has to be on one side of the line, either the top or the bottom, or left or right. Okay, so the question is, which side is the area on? That's basically what you need to find out. So there's a simple way to find out, and the way is to just pick any point, any convenient point on one side of the line. Like in this case, for example, if I have this line, I can pick the origin, just 0, 0 for the y, and substitute the x and y, the 0, 0, into the inequality and see if it is true. Because if it is true, that means that point falls in the area that I want. If not, then it is the other area. So let's try that. So I have this line, Alright, I want to know whether to satisfy this inequality, I want to know whether the correct area is this side or that side, below the line or above the line. So what I'm going to do is I'm just going to pick a point there, below the line. Convenient point is 0, 0. Right? 0 is always simple. So x is 0, y is 0. And I'll substitute into this equation and see whether, substitute into this inequality and see if the inequality is satisfying. So let's put in the 0 and 0. 0 is less than 0 plus 2. Is that true? 0 is less than 0 plus 2, which is 2. 0 is less than 2. 0 is less than 2 is true. So that means that this is satisfying. So that means that this point, which is below the line, satisfies the inequality. And therefore, it also means that the whole area below the line satisfies the inequality, and that's the area that we want. So same conclusion. Now you could either do it this way or do it by rearranging into this form, rearranging the original inequality into this form. Okay, because if you use this second method of picking a point and substituting into here, you don't actually have to rearrange the original inequality. You can actually just plug it right into here, into the first inequality. Right, if you remember, for the origin you have 0, 0. So 0 plus 0 is less than 2. And then you can tell that the origin is at the right area. So therefore, okay, we have found that the correct area is below that line. It will be the whole area that is here. Okay, it is this whole area here, and this area is not allowed. So how do I shade that? Well, I can shade this whole lot here, but wait, we are talking about x and y that must satisfy all three inequalities. And we already know that for the first two inequality, we have this area there, in this funnel-like region. Okay, that was the area that satisfied the first two inequality. So now we have a third inequality comes along, and we have found that the area for the third inequality is the whole area that is down there. Alright, the whole area here contains x and y values that would satisfy the inequality. So what we must now have is an area that satisfies all three inequalities. And that would simply be the area that is common to all three. So we have this area there for the first two inequality, and for the third inequality we have the whole area below the line, and when they overlap we have the common area. That is the answer. So we just want this common area, we don't want this part that extends outward for the first two inequality. So let me clean that away. There, we have a triangle there. So the solution to these three inequalities, the solutions are all the points, all the possible x, y's inside this triangular area. We'll stop here now. See you next time.